Our final beauty, which the first part is very easy in problem 75. This is very much like our flying pigs lab. You know the length of the string, you know the angle that it makes with the vertical, and the mass, and you need to figure out the speed. So a radius you find as length of the string sine of the angle with the vertical, so it's sine of 30 is half, so it's 0.75 meters. Then you set your centripetal force as your tangent of mg, and that is because of this triangle right here. That's mg, that's your centripetal, that's your 30. Tangent of 30 would be centripetal over mg, therefore centripetal is mg times tangent. Mass cancels. You end up with v squared over r equals g tangent of 30. You know everything but v, so your v is going to be square root of gr tangent of 30, and it's 2.1 meters per second. Fun starts in B. Heavy on algebra / trigonometry, that kind of thing. So, again, since this is a rotation, you still start with mv squared over r. You don't know r anymore, but you can again express your r as the length of the string sine of theta. Mg tan of theta is your centripetal force, just like before. Then mass cancels, v squared over L equals g times tangent times sine. Now tangent times sine is like sine squared over cosine, and sine squared is like 1 minus cosine squared. Voila! Tangent times sine equals sine squared over cosine. Sine squared is 1 minus cosine squared. So then 16, which is v squared, right here. So v squared equals gl tan sine blah blah blah. So gl v squared, since they tell us that now it is rotating with 4 meters per second, hence your 16, which is v squared. 1.5 is the length of the string, g 9.8, and then 1 minus cosine squared over cosine. So then notice this is the substitution, this is the algebra. The algebra started from here. Physics basically exited. Elvis left the building. So 16, what I do first with this whole enchilada here, I multiply basically everything by cosine, and replace cosine with x. So 16 times x. Then we have 14.7, which is the product of 1.5 times 9.8, minus 14.7 x squared. So this right here is 14.7, this right here is 14.7. That is not multiplied, this one is not multiplied by anything, and the second one is multiplied by x squared. So hence x 16x equals 14.7 minus 14.7x squared. Redistribute, get it into a quadratic equation. I am not a big fan of discriminant. I just went ahead and Desmoded it or graphed it. You can graph it in your calculator and figure out your roots. And one of the roots is almost 1.7. As soon as it's more than 1 and it's supposed to be a cosine, you know that's not it. So your choice is 0.594, and then if cosine of theta is 0.594, then theta itself is 54. So that is how you figure out the second one. And oh my goodness, I couldn't remember it right away. It took me some time. So I apologize for it being so late. If you don't finish it in time, no worries. Blah, blah, blah. Third one. If the cord is withstanding a maximum tension of 9.8 newtons, what is the high speed at at which the ball can move. So realize again that your force of tension is responsible for two things. It's responsible for supporting your force of gravity, and the other part of it is going to be providing the centripetal force. Any more than that, and it's going to break. Now, the thing that doesn't vary is the fact that you have to support mg, and mg is going to be 0.5 times 9.8. You cannot go around it. So, right here, T, which is tension, times cosine of theta is going to be mg. Therefore, tension is going to be mg over cosine. Now, mg is 0.5 times 9.8 over cosine equals 9.8. That gives you the idea that cosine, oh, did I not finish it? Oh, just thought about it. Then cosine of theta equals 0.5, which makes that a known value of 60 degrees, because cosine of 60 equals half. So that is my conclusion, that the maximum angle that that string can make is 60 degrees. Well then, if the maximum angle that the string can make, I go back to the beginning. Remember, we had this lovely thing, and we knew the angle, and that's how I knew the radius. Now I am just figuring out the angle, and I need to remember that my radius is going to be 1.5 cosine, 1.5 sine of that angle. Again, that is because that's the length, and it's opposite. You see through the side, so therefore it's sine. And then all that I need to multiply by tangent of 60, and when I plug it into my calculator, I get 4.7 meters per second, which happens to be the answer. Yay! The end. Good luck on the test. And by the way, nothing on the test is going to be that hard. The first part is as difficult as it gets on the test. But if you can figure this out, you are golden. Bye-bye.